Today, our colleagues from UC San Diego will present about TritonGPT, a solution built on an advanced open source large language model that is capable of answering a wide variety of questions about UC San Diego and more, which we'll hear about. So we will have some time for questions at the end, in the middle and kind of the end of each segment of the presentation. So please put your questions in the Q&A and I'll make sure to surface those when the time is right. So today I would like to introduce Brett Pollak, the Project and Change Lead, Director of Workplace Technology Services, Information Technology Services at UC San Diego. Welcome, Brett, and take it away.
Thank you very much, Kara. Hello, everyone. I'm super excited to be here with some of my colleagues here to talk to you today about TritonGPT. I am Brett Pollak, Senior Director, Workplace Technology Services. And as many campuses are doing right now, trying to figure out how to harness and wrangle AI, given all the effort and focus in on this technology in the community, in the technology community. The AI service line is underneath my purview, so I've been the lucky person to kind of figure out what we're going to do to wrangle it at UC San Diego, at least in the administrative space. And I'm going to pass it off to Adam Tilghman to introduce himself.
Thanks, Brett. My name is Adam Tilghman. I'm a principal architect and analyst with our Academic Technology Services unit in Information Technology Services. My work until recently has mostly been in the research and instructional space, helping our faculty and students make use of machine learning and data science technologies for their work. And it was a natural collaboration for me to come on over to the other side of ITS and work with Brett to get this project up and running. I'll go over to Jack Brzezinski, who's our IT expert, I'm sorry, AI expert, and that we have brought into the campus. Jack,
yes,
take it away.
Hello, Jack Brzezinski. I'm a senior AI architect on our generative AI projects. I work with Brett and Adam and the rest of the team and trying to get the TritonGPT architecture kind of move it forward and enable new features. So yeah, that's kind of the area of focus for me here.
Great, thanks a lot. I'm going to go ahead and see if I can do a screen share. So we got a few slides. I'll jump into a demo and then I'll pass it off to Adam and Jack to kind of talk about some of the technical aspects of TritonGPT. So, just in a little background in terms of, and I know I've talked to a lot of UC colleagues about, what they're doing in terms of, AI or generative AI on their campus. And so it's been super interesting hearing all the different stories and I guess different attitudes maybe at both the senior leadership level and on the ground about, kind of the opinions about generative AI and pros and cons and, things that either we maybe want to be cautious about in terms of unleashing or making available to folks, or just jumpstarting and getting our kind of hands dirty with this technology and getting it in front of people so that they're starting to use it and figure out how we might be able to harness it to make folks more efficient in their jobs. And so that really has kind of been the focus of us, looking at the release of commercial tools like ChatGPT and Google Bard, now Google Gemini, Copilot from Microsoft. As a lot of these technologies became available and our staff started using them, they approached us and said, what should or we should not be putting in these tools. And at the time, we really didn't have any contract in place with any of these providers. And so we were obviously very cautious in terms of our guidance. We were saying, limit any interactions you have to P1, P2 data at most, and ensuring that, we are looking at alternate solutions, both contractually with these organizations and these companies, in addition to kind of looking, is there something that we could potentially do ourselves in-house? And so, as we started engaging with, the Microsofts and the OpenAIs, and as we started to do some calculations about what it would cost to make some of these things available to a broad audience in our community, looking at monthly fees, anywhere in the neighborhood of $20 to $30 per month, per user per month, And you quickly do that calculation and you realize that there's not going to be a good opportunity to scale this very far. I know there's been some universities that have kind of taken the approach in which you integrate in with an API through OpenAI, for example, through our Azure agreement that we have with Microsoft. But even in that case, you still have to pay for tokens and usage. And so as you're starting to promote maybe these solutions, there's kind of an unknown when it comes to what this total cost would be, over the long term. And so for us, what we started looking at, and that Adam will get into a little bit, is just we have a data science and machine learning platform that we're already using and have been using for about 6 years now in our teaching and learning space. So it has, Jupyter notebooks and a lot of the technologies needed, for data science kind of work. And so knowing that, we could potentially bolster this environment with additional GPUs and things of that nature, that we potentially could leverage something that we already had in place and build upon that, and then look at that as kind of the foundation and basis for leveraging, some of the open source models that realistically were pretty close to being on par with where, at least OpenAI GPT 3.5 was. And so I saw a question too about, is the Llama Llama based? So yes, we are running Llama 2 as our large language model in on the back end powering TritonGPT. We've also brought in and looked at Mixtral, another open source model that seems to be kind of on par with Llama 2 in terms of some of the benchmarks. And so, we know that, with this environment that we're in with these large language models, shifting and coming out in such a rapid pace, that there's always going to be something better on the horizon, right? So kind of going back to, what we've done in terms of our approach is that, we have the San Diego Supercomputer Center, which we are obviously closely aligned with here at UC San Diego. And so we have been using that as the basis for a lot of these frameworks that we brought in. We know that we're going to have to offer other generative AI services that are part of, say, Microsoft Copilot or Google Gemini. Zoom has their AI companion. So we've been looking at these kind of case by case, knowing that TritonGPT is kind of this broadly available, or at least that's our target, is making it broadly available to employees on both the campus and health sciences side. But then knowing that we're also going to have to look at some of these commercial products and that are kind of embedded with these vendors to kind of do more purpose-built deployment of these AI solutions that are obviously now part of most commercial software packages, or at least on their roadmap. From a timeline perspective, just to kind of give you a snapshot of where things kind of started, we have an AI community of practice that started at IT services that we're a part of. And it basically was just a lot of people that were kind of experimenting with generative AI solutions kind of on nights and weekends. And so we came up with some ideas for some things that we might be able to do. And so, one of the things that someone was discovered, one of our student workers actually, was an open source framework from a company called Dancer. And so they actually are two UC San Diego alumni that came and presented at one of our AI communities of practice. And so everyone got kind of excited about the technology, basically linking, large language models into, context-based use cases around harnessing the type of information that we have on, hundreds of websites that are out there, or, Atlassian, Confluence, wikis and Google Drives and those kinds of things. And so we saw a real neat opportunity to be able to partner with this group to kind of create the idea behind TritonGPT, which really would be merging that large language model. And we did select Llama 2 for our initial use case, and then linking that into some of the context that we have on websites throughout UC San Diego. So we deployed a pilot back in October of 2023 with working closely with Chris and Yu Hong. And on November, we gave a demo to our chancellor. Our chancellor really liked this idea, and it was really into embracing generative AI for the purposes of trying to make our administrative population more efficient. And so his edict was really just to get it in the hands of some kind of handpicked people across the organization that was represented across different vice chancellor areas, get them using it, get some feedback, figure out if it's going to work for a broader population, and then make that determination. So he did give us some seed funding that allow us to purchase some additional hardware. So Adam was able to work with a lot of our vendors to try to figure out how we could circumvent the supply chain issues that have been going on with some of these commercial vendors. We were able to get some hardware installed in the environment here in January and February timeframe, while we were working to kind of work with our community to kind of fine tune things in terms of the answers in the system. We set expectations. We let people know that, you know, the system can hallucinate. It's going to give you wrong answers. But you also get wrong answers when you go out on Google and you try to get an answer to a specific question, depending upon the website that you're searching on. So, you know, the fact that we were bringing in UC San Diego context with the solution, you know, allowed us to be able to look at those documents that are surfaced for certain kinds of questions, and then be able to boost and suppress those within the system to try to, you know, get it to have more and more accuracy over time. So we did create, you know, some facilitated sessions, which I'll kind of touch on in a bit. But with that, now that we have the hardware in place, we are looking at rolling this to all employees on both the health sciences side and the campus side, and not, you know, kind of excluding our patient care side, just because it's a different way of doing business and they have a lot of different data sources that we don't use necessarily on the campus and health sciences side for the context. And then, you know, look at deploying that over the next several months. So we would target having all employees enabled in the system beginning at the end of May. So with that, we did do a lot of these kind of facilitated user sessions. And so as part of this, we had a partnership with our Operational Strategic Initiatives group. They worked with us to engage our user community, you know, come up with different ways in which we could get feedback. And we do have mechanisms to provide feedback directly in line within the system itself. But, you know, just getting folks to talk about, you know, what's working, what's not working for them in some of these ideation boards. And so they were really good at being able to, you know, kind of put this out in front of our end users and then funneling this back to us, and then us being able to kind of, through prompt engineering and then other techniques, you know, within the Dancer framework, be able to fine tune things a bit further. So this is just a snapshot of one of those idea boards that folks that we were able to pull together with OSI as part of this feedback. So we saw that people were using this for a multitude of different reasons, right? You know, looking for campus services and amenities. A lot of the use cases were around HR, professional development, you know, career growth, those kinds of things. And so it was interesting to see, you know, what people were using it for. And so, you know, we could then kind of fine tune things a little bit further. You know, policies and procedures was a big one, right? And so, you know, with the multitude of policies that are out there at UCOP and UC San Diego specific, you know, we saw a lot of policy related queries in the environment, things related to contracts. And so IT related questions, what group supports, you know, X, Y, or Z platform? Those were things that folks were, you know, asking of TritonGPT, and how to simply log into a system. So it was kind of interesting, and on the back end, being able to see how people were interacting with it, and then again, kind of helping it to be more and more accurate over time. So with that, I'm going to jump into a little demo. I am going to kind of log into TritonGPT here. This is our interface. We have a couple different assistants that are associated with it. We have our UC San Diego assistant, and the UC San Diego assistant has all of the UCSD context behind it. We also have what we're calling a general AI assistant. So this general AI assistant does not have any UCSD context. What it does is it opens up the context window, so it allows for more tokens. So yeah, it basically is Llama 2 kind of straight out of the box. So you're able to interact with it from that means. We do have something else called a JD helper. And so similar, I think, to you at UC Berkeley, our chief human resources officer was getting a lot of questions about appropriate use and how people were using generative AI to develop things like job descriptions. So that was one of the early use cases that we kind of adopted, was helping our hiring managers being able to write job descriptions in an efficient way using generative AI. So let me just jump into a quick demo on Job Description Helper. So what we did was we fed over 1,300 job descriptions, the career tracks job cards, into the system. And so basically it uses that as retrieval and allows the hiring manager to interact with it in kind of a natural language format to develop a position overview for a job card. And so as an example, let's say if I'm hiring a data systems analyst 4, the system now is going in and retrieving that data systems analyst 4 job card. And now it's saying, please provide any and all relevant details for the job. So I am just going to copy some information about how I'd want to customize this job for the specific role that we're hiring for. So I'm saying part of the business intelligence and analytics team, their responsibilities, deep understanding of SQL and our data warehouse, and they'll be working on SAP HANA. So we've seen that hiring managers could just input a bunch of technical details, right? And so this hopefully gives you kind of a good first pass at creating a position overview. So if I just enter this into the system, what this is doing now is it's merging the text that I put in there with the actual template job card that is in the career tracks library. So it's outputting, at least a good first cut from some of the analysis that we've had with our HR community. They've seen this as something quite a bit better than what they typically see from a hiring manager, at least as a first pass. And so we're excited to continue to help and fine tune this and embed kind of more language in here as we continue to test and refine. So just to kind of show what exactly it's doing, we do have these career tracks job cards. This is the data systems analyst 4. We are basically passing this information in here with it, and it's using that, combining it again with the custom information that I put in there to output this as a first cut for the position overview. The UC San Diego Assistant, we find that people are using this in a multitude of different ways. As I said, we had got some starter prompts in here that people can use. So if I click in to say, what is an IDC rate, and our cloud service is exempt from IDC, this information is on our intranet. So it's being pulled in from source pages that is pulled into the context, and then it's using that Llama 2 basically to provide the natural language on top of this. So it's giving me some good summarization here of what an IDC is, or indirect cost rate. And then it's providing the source documentation that I can click on and then go to get the actual information that I need to use to validate the answer provided by TritonGPT. So we definitely encourage all the users, and we do have training sessions that we've provided folks that we really reinforce that you have to go to the source documents in order to get the right answer. We do have, in this footer here, asking folks to check all the sources and policies and laws. Obviously we do see, things hallucinating within the system, but we really do encourage that folks go and hit the source documents in order to validate anything that's being provided in the system. There's, it can do everything from citing policies, procedures, and answering, specific questions around IDC. It could also, if I'm hungry, I might ask it, something like, what restaurants are open right now that serve sushi for lunch? So it goes and looks at some of the dining information that we have on our intranet. It'll pull back some specific restaurants when they're open. So it's good for kind of fun things as well. Parking and transportation, if I'm going to a building, I'll often ask it where I might be able to park, and it provides that information with a link over to the map in the source documents. So it's real convenient when it comes from that perspective. It is mobile friendly too, in responsive design. So if you're doing it on your mobile phone, it's going to look good there as well. Yeah, I mean, that's, some of the use cases that we have around it. Faculty are also engaged and are starting to use the system. Again, we're kind of keeping it to the administrative side as much as possible to begin with. We do have a faculty senate that's convened now that is looking at kind of best practices and guidance for faculty from a pedagogy perspective on how they could use generative AI. So we're waiting for that guidance really before we do anything broadly in kind of the teaching and learning space. There definitely has been some interest with faculty wanting to integrate Canvas course information. Also, some of the presentations and the collateral that they have, in teaching the class that is stored in things like Google Drive, and basically merging that together and creating kind of a teaching assistant using this as kind of a backend. So as we start to get some of the guidance coming out of the academic senate, we'll be interested to see, what we can do to kind of support the teaching and learning side with TritonGPT. So again, this is indexing our policies. It's going to pull back the policy information related to that. So we see a lot of faculty inquiries, around what they're able to do or not do, given the policies. Student conduct, those kinds of things, those kind of answers are surfaced obviously easily through a system like this. I'm going to pause here and I'm going to look at the Q&A, and maybe Kara, if you can help me maybe surface some questions that have come up that I'm happy to maybe answer and pause before I turn it back over to Adam.
Sure. Thanks, Brett. We've got a number of questions in the Q&A. Some technical questions. Have you quantified a wrong/correct answer ratio?
I'm sorry, you kind of clicked out towards the end. A wrong /
correct answer ratio.
A ratio? That's actually an interesting question. Jack, I mean, what are your thoughts? I know you do a lot of analysis of the answers in the back end.
Yeah, I think that right now it's kind of difficult to say which questions are real, which questions are tests. So our initial groups of users, we openly told them that, hey, you are testers. So if we look at the logs of the interactions with the system, many of those interactions are just openly testing different versions of prompts, different kind of approaches to asking the TritonGPT. So on average, I think we are kind of 50-50, like thumbs up, thumbs down kind of ratio. But it's, like I said, it's probably not a real kind of usage test, because this is a group that is basically helping us tune the system rather than just kind of run it in production at this time.
Yeah, I guess just to jump in on that too. I mean, I think by and large, what you're going to see is people are going to thumbs down and provide the feedback, because that's really what we've encouraged, right? So in general, I've talked to folks just anecdotally, and they'll say, yeah, no, it gave me the right answers, but I really didn't give it a thumbs up because, I just felt like, I wanted to focus on improvement as opposed to just reinforcing what was already right. And then, in addition to that, I think, from our standpoint in some of the facilitated sessions we saw, I think it's kind of training people how to use generative AI to get the most out of it. So just being able to kind of format your prompts correctly to try to get the correct answers. So there's kind of a best practice around citing your goal, citing the context, and then the action that you want the large language model to perform. And so when we're in those sessions and facilitating that with end users, and they realize that, they're getting much better results afterwards. And so part of what we've done with the rollout is deploy some generative AI training, some prompt engineering training that is facilitated by our OSI group. So we'll continue to do that in like an office hours format. And we have some webinars that we've recorded and making available to the community. And it's also available via UC Learning. They've also, and I believe Bill too, they made those available so that it kind of strips out the TritonGPT specific things. And so now other universities are taking advantage of that as well.
There's a question here about on the hardware side. How did you plan for scaling this, or limiting/throttling/prioritizing use of it so that your on-premises configuration isn't overtaxed? What monitoring do you have in place around this?
Adam, you want to take that one?
Yeah, I'll take that. So I'll start with the monitoring first. We have analytics coming out of both the large language model and all of the application components, and those are flowing into several different analysis tool so we can look at activity from different perspectives. Regarding hardware scaling, I think probably the language model would probably be the weak point. And so what we've done there is we've done extensive modeling of essentially the number of parallel users that a given quantity of hardware can support. And that was informed through some of our earliest testers that came in November and December. We were able to get a little bit more insight into typical user behavior. How many seconds delay did they typically leave between chat prompts and follow-ups and things like that? Those are really those are the factors that drive the ultimate load on the most expensive part of the hardware, which are the GPUs. And that's really what we focused on, was making sure we had the GPU capacity. The other aspects of the system, storage, CPU, networking, those are all pretty familiar territory for us, and we have enough excess capacity elsewhere to pull in as needed if we run into any problems.
Thank you, Adam. Question here: how frequently is your AI reading the internal web pages or documents to make sure it's giving the most up-to-date answers? And a related question is, how much additional training do you do on top of the Llama 2 model so that TritonGPT can be aware of the UCSD context? And how is that training done? So, the alignment with the content and the frequency, and as well, how is the training done?
So it's updated nightly for the most part. I believe the agents run every night. Is that right, Jack? Adam? Yeah. So the agents run nightly. It'll pull up the updated information into the system, into the vector database. And so it updates on a pretty frequent basis for all the websites that are pulled in as part of the context. And then, sorry, what was the other part of that?
Yeah, the second question was, how much additional training do you do on top of the Llama 2 model so that TritonGPT can be aware of the UCSD context? And how is this training done?
So there is some inherent things that the Dancer framework gives us in terms of being able to boost or suppress content within the environment. I would say that obviously helps. The other part of it is prompt engineering and prompt tuning. Jack, do you want to touch on that?
Yeah. So essentially, well, training can mean several things in generative AI context, right? So we are focusing on RAG architecture, which we will have in the next slides, which is basically that we are creating a vector space of embeddings in our Vespa database, and that is basically the knowledge base for the AI, right? So once this is in place, then training can have a couple of different kind of facets to it, right? One is that you can prioritize certain vectors in Vespa, right? And the second thing is that you can change your system prompts to actually kind of refocus the AI on certain features in text. Like we spend a lot of time, for example, on refocusing the large language model to properly cite resources, right? So to have really solid references whenever possible, right? So these kind of things we are doing right now. If the question is about fine-tuning, we are not fine-tuning models yet, but I think that's also something that could be on the table for the future.
That's great, thank you. Just to make sure that you both have enough time to present, maybe we can move on to Adam or Jack as well, and we can continue to answer the questions in the Q&A during the presentations and after. Sounds
good. Keep the questions coming.
All right, everyone. So as Jack was alluding to, the TritonGPT is based on what's called a retrieval augmented generation model. Probably has been discussed quite a lot within your community. And so that model depends on an external source of curated content. And that's where I'm going to start here. We are right now pulling in public UCSD data for the most part, and crawling the web much as Google or other search services would do. But the list of targets and the rankings and the weighting, those are set by business owners, content owners here within the university. And that's really how we can point the output of this system, or rather ensure that the output of this system is accurate and consistent with UCSD policy. There are some areas I saw a note in the chat regarding Tapioca Express not actually serving sushi, as Brett had found. There are some areas that we have not yet covered with that content curation. And in those cases, you will see hallucination. And so one of our efforts is to work with the business community, to work with the content experts to ensure that any areas that are important to UCSD operation can be curated properly. So in the retrieval augmentation generation model, the documents are loaded, as Jack mentioned earlier, into a vector database where the entire the contents of a paragraph or perhaps the whole document are converted into a very wide numeric vector. And those vectors, all of the vectors in the database corresponding to all of our content, are compared with the user's prompt. And from that, a set of candidate documents is obtained. And those will be fragments, like I said, of individual documents. It could be, in some cases, tabular data, PDFs, etc. The application framework that we're using, Dancer, which I'll talk about in a bit, has built-in translation capabilities for various types of content. Once the user's prompt, where can I get sushi, and the relevant information are compiled, that information or that collection of information is then passed along to our large language model. And that goes by way of an API gateway. We are looking to a future where we may have other batch processes or other applications that may want to make use of our inference infrastructure. For now, and probably for the next several months, we are looking at TritonGPT as being the only user of our VLLM until we get a better handle on its overall capacity and capability. Let's see. In addition to the public web content, we are looking to pull in data from our various campus data warehouses, such as facilities, research, employee data, and the like. And that's going to be handled through an integration with Wolfram Alpha. And so we will utilize the planning capabilities of Alpha to generate queries against those data stores to bring additional facts that will then again supplement the user's prompt. And then we'll rely on the language model to perform the final natural language analysis. Pulling in data from institutional data stores will raise privacy and security concerns. We would be dealing with P3, potentially some types of P4 data. And it's for that we are working with, or it is to address that concern that we are working with some faculty members here on campus who have launched a commercial product that performs a one-way encryption and perturbation on those documents that are being passed into the large language model so that they are still equivalent in terms of the language model's understanding of the data, but to the outside viewer, they are gibberish. And the process that they have built out ensures a relatively strong level of security for that data. Then that's the data going into the model. The answers coming out of the model, those would still potentially contain private information, and that's an open question we're dealing with right now, how to protect that as well. And then finally, there was a mention of fine-tuning. I'll cover that in the next slide. So we are using the VLLM inference engine So this is the code that takes the user's prompt and runs it through token by token through all the layers and the billions of parameters of our language model. We are using Llama 2 right now. We made a decision early on to stick with Llama 2, even though several others have come out in the meantime. We wanted to get TritonGPT out and released on a stable platform, but we've architected the system so that it will be easy for us to run additional models like Mixtral or fine-tuned versions of Llama, or even Llama 3, if and when that comes out in addition. And we'll be able to pivot the data flow into those models as needed. We went with the VLLM inference engine over a number of others that we evaluated. That includes NVIDIA's Triton Inference Server. There's a tool called llama.cpp, which is very popular for people running models on their desktops. FastChat and several others. We found VLLM's attention to speed and scalability compelling. It comes out of Berkeley's LMSys group and the Sky Research Lab. Those are groups that have been really spearheading the intersection of distributed system design and machine learning operations. And so they built a system which is highly parallelizable, supports thousands of parallel streams of inference at the higher end, but does so in a very memory efficient fashion, preserving the resources on those GPU cards and consolidating different prompts or different query streams to conserve that memory. It also provides performance metrics. I mentioned those earlier. Those have been very useful to understand the impact of these large prompts, especially prompts that are supplemented with additional documents, and to understand how many users we will be able to support. Right now, we're running the system on 4 H100 GPU cards. We have a couple additional sets of those cards available should we need them, but we're fairly confident that those 4 GPUs will carry us through the first several months of release to the campus. The performance, the VLLM has been exceptional at combining all of the parallel input streams. And let's see, the other, I guess the final aspect of VLLM that we're very happy with is the pace of rapid innovation. As new techniques have come to light within the academic world, and so this would be things like hosting multiple fine-tuned copies of a single model at the same time in parallel without having to actually dedicate the resources to each one of those models. We can efficiently serve them all at one time. Prompt caching is another efficiency improvement that has come in recently, and that allows the VLLM engine to store and retrieve previous prompts that have come in. And so if we have multiple people consulting the same set of documents or the same question, we can be even more efficient. And then finally, they are rapidly taking on new hardware architectures, which brings us beyond NVIDIA and their GPUs, and potentially allows us to expand out into cloud offerings should we just find the need to grow beyond our local capabilities. So Dancer is the framework that we are using for that retrieval augmented generation. It was built by a couple of UC San Diego graduates, and it is purpose-built to perform enterprise retrieval augmented generation retrieval. As Brett showed, it features a number of connectors. We've built in, or we have made use of several existing connectors. but we are also have been building custom connectors. And so we found that flexibility that they created very helpful in adapting this generic tool to our local context. So it's another example of Dancer's retrieval flow. When Dancer first consults that vector database to determine or to identify relevant articles or data pieces, it will first run those through the LLM behind the scenes to identify and rank that content, so that only the most relevant content, according to both the embedding model and the large language model, are ultimately passed to the LLM to answer the user's query. All right, and then next I'm going to hand it off to Jack, who's going to talk about some of the other tools beyond Dancer that we've been looking at.
Yes, thank you, Adam. I think behind the scenes, there's a number of interesting things that are going on that will continue developing and extend the capabilities. I've seen a few questions about what's next, whether it's going to be maybe multimedia content in play or kind of next generations of capabilities, right? So I think the answer is yes. So obviously we will continue expanding because Dancer as a platform is based on very commonly used libraries like LangChain and Llama Index, and there's some capabilities that we are not tapping into, very heavily, and we can. So obviously, tool selection that you can see here is something that is on the table, and we have a few slides down the road here where we will be kind of showing the plans. But essentially, right, we don't have to call only one thing, right? So to provide an answer, we don't have to only interact with Vespa, our vector database. We can kind of look for search engines and maybe go to Google Scholar, or maybe go to other resources that exist within the university to kind of get answers. So, for example, there are other AI systems currently in place that are answering very specific questions, and perhaps TritonGPT should be redirecting the prompts to that location. Also, one more thing that maybe was not obvious from our presentation is that there is a secondary flow within Dancer that is verifying the quality of an answer. So there was a few questions about, hey, maybe sushi is not there, or maybe how do you know that your answer is correct? So obviously, those are big questions. And one thing that is happening behind the scenes is that we have a system prompt mechanism that is asking the LLM whether the answer provided based on the retrieved vectors from Vespa and the large language model processing of those answers is actually relevant to the original prompt that has certain semantics and that has certain meaning. And if that answer is kind of drifting maybe away semantically, then our setup is internal setup is basically going to say that the large language model is going to respond, oh, I don't have very accurate information on that subject matter. However, here's what I've got, right? So there's some mitigation of problems that are kind of along the lines of the agency capabilities that we have. Next slide, please. Yes, another capability that is going into the direction of available libraries and what can we do kind of on the back end is that there's certain things that we can expose to users as GUI based kind of models of interaction. So what you are looking here at is a graphical interface called LangFlow. It's a graphical interface to LangChain. So this is a very interesting proposition because it basically allows you to create something maybe like a digital twin of your main system. So here, just with dragging and dropping things, you can create a reasonably sizable vector database that is going to be your RAG, resource. You can also create your custom prompt structure that you can use for testing. And something that I've been using quite a bit is also, as an analytics tool on the log files that we are generating. So I can have a generative workflow within Langflow that we are looking at to actually analyze, various aspects of what is going on in logs, how people are interacting with the system. So as an analytics tool or as a kind of prototyping tool, this is a very rapid development kind of a deal, which could be desktop based, right? So I can hook it up to our main Llama environment, or I can hook it up to something like a very small Mistral desktop, model like Mistral 8 or something similar, and then just kind of run the prompts, on the reasonably fast laptop. So that's kind of an interesting capability here. Next slide, please. Yeah, okay, so that's kind of like what is next, right? So the next thing is that well, what if we would like to take a look at other sources of information, and generally speaking, maybe structured data sources. So what if we would like to take a look at the Activity Hub tables and use those resources to answer questions? So this will be our next step, where we will be using the Wolfram framework to help us interact with databases through basically a conversation with an SQL generation pipeline. So the workflow that we are looking at here is that a question that will contain semantics that is pointing to maybe a student activity hub, maybe about something related to degree programs, like how many students are in the cohort that are taking, introduction to math or something of that nature. That's clearly something that needs to be answered with a database data sets. So this conversational system will generate SQL statements. Those SQL statements will be executed against the HANA column groups, and then the result is going to be compiled by large language model, and either provided in a textual format or provided in a graphical kind of environment, where this kind of pipeline basically creates a conversational BI tool with SQL access to our databases. So there's several steps that need to happen for this thing to be operational. And again, one of the things that we are working with our generative pipelines is that we need to create a very solid metadata for our Activity Hub column groups, so that the large language model is aware of the information semantics that we have in our databases. So it's kind of a huge discussion here, perhaps a topic for another webinar, but anyway, this is an exciting capability here. Next slide, please. Yeah, so this is kind of what I'm talking about, in a little bit of maybe technical detail, where the vector space on the left-hand side, the metadata is actually residing in our Vespa vector store. So if that's the case, right, this is an exciting capability, because we can use the retrieval portion of our dancer flow, which is utilizing an E5 large embedding model size. So it's basically a 1024 dimensional vector that is searchable through basically a BM25 retrieval model that is assessing the similarity between the user prompt and the vector space representations. So if that's the case, then the SQL generation process is going to be informed by an extensive metadata that we are generating with generative AI, procedures, kind of a separate thing. And so the SQL statement is going to be aware of the semantics of our databases, right? And that if that's the case, then we already confirmed that the SQL quality, the SQL generative qualities of the system is very high. So so the battle that we need to win is basically on the metadata side. We need to represent our databases very well in that respect. Next, please. Yeah, so while we are watching here on the left-hand side, there was just basically a natural language question that can be asked you to formulate SQL. Now, so here's an example how this might be further extended, because the Wolfram environment also has a tremendous resources in them. So there is something that is very attractive, which is a curated knowledge base of facts, and those facts are very important for maybe educational applications that we certainly will have. There is also census data. So for our fund management applications on the administrative side, if there's let's say a question, how do we predict enrollment, right? What's the zip code analytics that we would like to do to assess maybe the enrollment level for the next year? That information is going to be sitting there, so we don't have to look into enrichment data sets like Personix or Melissa or something like that, where there's basically a third-party census data. This stuff is going to be within the private cloud, within without our resources, computational resources. Another thing that is very attractive is that Wolfram also has, as you probably know, Wolfram language, which is a very capable tool to maybe build predictive analytics and visualizations and things like that. So on the left-hand side, that flow that you see here on the left-hand side doesn't have to end at generating an SQL statement and maybe I don't know, maybe creating a Python code based on that or some sort of a visualization. It can be a confluence of several things that we get from Wolfram. So that the answer could be predictive in nature, could be interactive graphically, and could be enhanced in terms of kind of the fact retrieval, right? So if application to calculus, for example, or to physics or to chemistry are kind of right in the box, so I can right away ask questions about chemistry problems or algebra or calculus or whatever we wish. There is also optimization libraries within Wolfram, right? So again, on the administrative side, allocating resources and optimizing them through some sort of linear programming approaches is again conversationally enabled within that environment. Next, please. Yeah, so here are some domains that we can look at, right away and out of the box, right? So there's, as you can see, there's in addition to those areas here, there is already personas that are generated that can be like a teaching persona or maybe a tester persona, or there is also personas like talk to me as if you are a king or something like that. So this is a tremendously interesting environment where currently the personas that we are developing, let's say for TritonGPT, the main system, and then for JD Helper, can be enhanced by personas that will be a chemistry teacher or a physics teacher, right? Or a fund manager that is focusing on optimizing things, right? So on the educational side and also on the administrative side, there is capabilities here that kind of come into play because there is a generative access to Wolfram language that can pull all those things for us in a kind of notebook fashion or however we would like to shape the interaction. Next, please. Yeah, so again, an example here, right? Write an essay comparing, two stars is kind of an interesting thing, because we know that the system is not going to hallucinate. It's going to reach into its own RAG architecture and kind of retrieve facts that have been scientifically confirmed, within the Wolfram environment, right? So you no longer are kind of relying on the neural network's knowledge. You are primarily relying on the knowledge base that is available there. So you can see the capabilities here. This is just a simple example where we are pulling the underlying facts and using the large language model to kind of generate, maybe an essay or maybe a poem or something that is going to be interesting for sure for several use cases. Next, please. Yes, so there was also a few questions about how do we kind of deal with evaluating the system and kind of controlling what's going on. So, Caliper is one of the ways to have like a deep, high granularity access to what's going on, and probably, having those insights into user cognitive efforts is kind of an interesting thing to see, and will be a platform for us improving the UI and kind of tuning the system so that it's responding to user needs. So I know that we don't have much time, but I think that, maybe we can answer some questions now.
I know Adam and I, as Jack was talking, and I know Jack was doing the same when Adam was talking, to try to answer as many questions as possible. Given that we only have a minute, I think just summarizing maybe some of the questions just were along the lines of, hallucinations and accuracy and things like that. We know this thing is not going to be perfect. And I think that was kind of our main message to the cabinet when we were looking at deploying this, was that, this is being braced by leadership at UC San Diego. It's never going to be 100% accurate. Large language models are prone to hallucinations, but we're going to be doing our best to make sure that we're, steering it in the right direction, given all the techniques that we kind of just discussed. So yeah, I mean, the kind of cost benefit of not deploying something like this broadly, our leadership has said, get it in the hands of people, getting them used to using it, teach them how to use generative AI. They also definitely see this as kind of a teaching moment in terms of how to get the most out of it. And as we maybe hit bumps in the road with maybe people citing some things that we didn't predict for, that will kind of focus efforts in that direction. But in terms of not doing anything versus doing something and just making sure it gets better over time, our leadership is leaning to the latter.
Thank you so much, Brett, Adam, and Jack, for a very interesting discussion and for answering questions from our community. It's always so interesting for us to hear what's going on across the UC system, how UC system universities can differ so much between locations, and also learn from each other and share knowledge. And we really appreciate all of our membership for coming today. And we will record the presentation, send out a transcript of the chat with all the great answers that Brett, Adam, and Jack have provided. And thank you so much for coming today. Thank you, Brett. Thank you, Adam. Thank you, Jack.
Thank you.